Here we have a piecewise defined velocity function, and we're asked to sketch the position versus time function from it. There's a point that the position graph has to cross, and that is given right here. It says it has to touch x of 3 equals -4. So I'm going to go ahead and find that point, go over 3 seconds, and according to the givens, whatever we graph has to cross through that point once. All right, so the first thing I'll do is I'll write out the velocity function in a piecewise defined way. It looks like it holds a value of -2 for 0 to 3. It looks like it holds a value of 1 from 3 to 5. And it holds a value of 0 beyond 5. Okay, now what I want to do is I want to find antiderivatives for each of these. Now let's find the antiderivatives of each of these. We're going to have -2t plus c1, t plus c2, and c3. These are the antiderivatives of -2, 1, and 0. And we have to find out what the constants are. So since the slope is -2, prior to arriving at the point 3, -4, we can actually just kind of trace it backwards to see where it came from. Okay. Next, it's going to proceed forward with a slope of 1 for 2 seconds. And then once there, we're going to have a velocity of 0, so it'll just go horizontal after that. So what are our functions? -2t plus 2 for 0 to 3. This one will be t minus 7 from 3 to 5. And then just a -2 from 5 on. Now it's not necessary that we have continuity down here in the velocity graph. However, we would like to have continuity in the position graph. So for that reason, I can put some equal to signs in there just so that it does have a value at t of 3. We don't want it to be undefined at that time. But that would just mean that my velocity has open dots here. Now in reality, the velocity of an object is never really undefined. It would be a smooth type of transition, something like this. But since we're modeling it with mathematics here, we're trying to take some of the complexity out of it and just make it as simple as possible. So we'll pretend like it instantaneously jumps from one velocity to the next, even though in reality that's not possible. Because if it did, it would mean it would have an infinite or undefined acceleration, which can't happen. Lastly, it wants us to find the average velocity of the object from t equals 0 to t equals 10. So for this, it's helpful to shade in our areas. Areas below the time axis will be considered negative, and areas above it will be positive. And the formula for average value of a function now is going to look like this. Okay, that's what we're going to need to do. We're going to need to add up the area under the curve and then divide by the total time interval. So we're going to get negative 6 plus 2 plus 0 over 10 minus 0. That looks like negative 0.4 meters per second. And there we go.